Hello everybody, in this video I'm going to be showing you how to toggle the visibility of a model by clicking on it. Basically just click on it to make it disappear and then click on where it was to make it come back. So first things first, obviously you need to have your model, and then we're going to come to replicated first here, and we're going to add a local script. And we'll call this user click detector. Now this local script is just whenever a client clicks on the screen, it's going to detect that, and it's going to run some code to see if they clicked on the model, because we can't use click detectors whenever a thing is invisible or can't be collided with. So we're gonna delete all of this out, and we're going to say local user input service equals game get service user input service, and then we're going to say local event equals game dot replicated storage wait for child user click, and then we're going to come into replicated storage and make a remote event and call it user click. So basically what this does is it just, line 1 here, just imports the user input service, which we will use to detect whenever the client clicks, and this event we will fire, which will be basically be able to send information to the server, and then the server will do some stuff to actually make the model disappear. Now we're going to come down here and say function get click pause or click position, doesn't matter. And now we're just going to define some variables. Local mouse location equals user input service get mouse location. Local screen to world ray equals game dot workspace dot current camera viewport point to ray mouse location dot x mouse location dot y. So basically this line 5 here, pretty self-explanatory, just gets the location on the screen of the mouse. This is 0, 0. This is all the way down there, not 0, 0. And then screen to world ray is we're casting a ray, like ray casting, from the screen, like where the user's mouse is, because of these parameters we're passing, into the workplace. Well, this is not actually the ray. This is just one of the numbers that we will use later to create the ray. Local direction vector equals screen to world ray dot direction times 15,000. So basically, this is just converting our position here, or the camera position, then the ray, into a vector, which we will then use to cast a ray on that vector. So the way we make a vector is we just multiply the direction by its magnitude. The magnitude is 15,000 because that is the highest number you can have, like the longest you can have a ray whenever you're ray casting something in Roblox Studio. And we will be able to change the distance, like if you want it so that the user cannot click on the object unless they're like within 32 studs or something. We'll change that later, but you still want to have this as 15,000 because this isn't actually the raycast we're using to detect if the user clicks on something. We do that later because if we did it here, that would be a little bit of a security issue. Local raycast result equals game.workspace raycast screen to world ray dot origin direction vector, and then if raycast result, then return raycast result. So this actually is the ray object, and then if it exists, then return it. So this function we will use later to get the position of the get the vector, or like the click, the physical location, the 3D, like the three-dimensional location of where the user clicks in the game. Now we're going to come down here and say user input service dot input begin connect function, and this will just detect whenever a user clicks. I'm going to say if input, and then we also have to pass an input parameter up here to detect which type of input the user is doing. So if input dot user input type equals enum dot user input type dot mouse button 1, then that just means it was a left click, or like, you know, like a tap on mobile or something like that. Tap on mobile would probably actually be touch. So if your game is PC only, then this would be fine. You might want to add a couple different types of inputs if you have some other stuff going on. Then we'll say local position equals get click position. So that's just calling this function up here. And if position, then we're going to fire our event that we made earlier with the position returned by our function up here. Earlier I mentioned that there would be a security issue if we use this for actually detecting if the user has clicked on the object, and that is because if we do everything on the client, then the client could actually do some hacking stuff and make the game think that they're, you know, right next to this model, even if they're actually all the way over there. So then they'd be able to click on this even if they're not actually within range. So we have to do determine if they're within range to actually click this on the server side, which they can't affect. So now we're going to come and we're going to make a new script in server script service, and we'll call this one user click handler. And then this script is the one that will be receiving the events that this script over here sends, and we'll be processing them. And we're going to say local event equals game dot replicated storage dot user click. So this is just referencing our remote event from earlier. Local model equals game dot workspace dot turtle. So this is referencing this turtle, our model up here. So we can later, we're going to check to see if this model is the one that the user clicked on. Local visible equals true. This is just an internal counter thing. And then local max distance equals 32. You can set it to whatever you want, anywhere from 0 to 15,000. I'll show you exactly how far 32 is in a little bit after we finish writing the script. Now we'll come down here, say event.onServerEvent connect function player position. So whenever you have a remote event here and you fire the server from the client, this first parameter is it automatically passes the player, the client that called the event, and then this position is this other parameter that we are passing here. Then we're going to say local character equals player dot character. So this is like the actual physical location, or like the physical model of the player, like the little guy that you play as. And now we're going to do a second raycast on the server side, which the client can't affect, so they couldn't hack this, to detect if the user is actually clicking on the model. So we can say local params equals raycast params.new params.ignore water equals true, and params dot filter descendants instances equals character in curly brackets. Excuse me. So basically what this does is we'll just pass this as a parameter to our raycast, and this just lets us modify the behavior of it and change what it does and does not consider to be a collision. So this just makes it so that if you do have water that you added like as terrain in your world, the raycast won't collide with the water, so you'll be able to click on something through water. And then this just makes it so you can't, like it will pass through your own character, because we're going to be casting a ray from the player's model, from the character, towards the position that we passed earlier from our local script, and sometimes it'll like collide with the character and it'll give inaccurate results. So this line just prevents that. I will say local direction equals position minus character dot humanoid root part dot unit times max distance. So with this, we're just making another vector here. This determines the first part of the vector that goes from the player's humanoid root part to the position. Dot unit here turns it into a unit vector, and you can multiply a unit vector by a distance to make it to basically just increase the magnitude of that vector to the distance that you're multiplying by, which is what we defined up here. So this line just generates a vector from the character to the point that they're clicking of a size specified by our variable up here. So again, you can change that to whatever you want, and I'll kind of show you a couple different values later. Now, local ray equals game dot workspace raycast character humanoid root part dot position direction and params. So this casts a ray from the humanoid root part to, or this, then this is the vector that the ray will be, and then these parameters, params, are just the parameters that we defined up here to make the ray cast behave a little bit more controllably. And then we'll say if ray and ray dot instance and ray dot instance is a descendant of model, then so basically this just checks to see if the ray exists, which it should. If the ray hits something, so this will be false, like if the user clicked off into the sky, and if the ray, the part that they clicked is a descendant of our model up here, which would just mean if any of these parts belong to the model, and I could even like group these as a folder and say legs, and this would still work. So this part basically just checks to see if the part that we hit is like under the model's umbrella, if it's part of the turtle. Now we have to iterate through every part in the model and change its transparency and collision depending on whether or not it should be visible or not. So we're going to say for underscore part in I pairs model get descendants. So this would be just a number that indicates how many parts we've done so far. So we don't need that, so we just put an underscore, which does not store a variable because we don't need that data. Part is the actual reference to the specific part that we are iterating through right now. And then this is just a list, basically, of all of the parts in this model. That includes the folder. So now what we're going to say is if part is a base part, then, so this just makes sure that it is like actually a part that exists and not just a folder. And I will say if visible, then part dot transparency equals 1, which will make it invisible, and part dot can collide equals false, and this will just make it so things will be able to pass through the model. And then we're going to say continue, and we'll come down here and say part.transparency equals 0, and part.canCollide equals true. Now this part can be a little bit confusing, especially if you're not familiar with this sort of thing. So basically, if the model is currently visible, then we execute this code, and then we skip this code, which is this more efficient than using like if-else. So if you have a situation where you could do this or if-else, it's always better to do this because it takes up less processing power, less time, etc. So basically, if the model is visible, then run this code to make it invisible, and then this continue here skips this code. And then if this is false, then obviously this code never runs, and the code continues on to these two lines, which makes it visible again. And then we'll just come down here and say visible equals not visible. Visible. Which obviously just updates the internal counter thing here. So it knows after a user clicks it again what to do. And that should finish everything. So now if we come here and play, and I look at the model and I click it, nothing happens. One moment. I believe, yeah. So this needs to be, that is my mistake, I apologize. Whenever in our function, in our local script, we need to say raycast result.position. We don't want to return the actual ray, we want to return the position of it. And then in here, same thing. We don't want to right now we're trying to subtract a part. We don't want to subtract the part, we want to subtract the position of the part. So that is my mistake, I apologize for that. And one more test, and as we can see here, whenever we click, turtle goes away. Whenever we click where the turtle was, turtle comes back. If we open up our console here, we can click other parts, nothing happens, and we can click into the sky, and it does not break. So that is, excuse me again, that's it. Now this does have some limitations. For example, this would only work with this specific model that we set up here. If you wanted to have multiple models, do it. I'll show you how to do that really fast. It is not too complicated. So we do have to make a couple of changes. First of all, we're going to get rid of this visible variable. Then we're going to change this model to models, plural. And we're going to put this guy in curly brackets. And then we're going to come down here. We're going to put this guy in square brackets. We're going to say equals true. So let me explain the structure here. Basically, instead of having one specific model that we'll check for, we'll have an object of models, and each one will have the location of the model and whether or not it's visible. So let's just say I wanted to have another model here. Just nothing too complicated. We'll do something like this, and then like this, and then like this. And then we'll group all of these together as a model, and we'll anchor this. Now this is this starts off visible. We'll make it so these things are not visible. So the transparency is 1, and canCollide is false. So this would start off invisible. So now whenever we reference this in our object, we would say game.workspace.model equals false because it's already invisible. And then we have to make a couple changes down here. As you can see, we have a couple orange lines under our variables, which just means that, excuse me, these variables don't exist. So what we're going to do is we're going to just iterate through this object, which I'll show you how to do here. So we're gonna come up on line 18 before this if statement. Put a new line. We'll say for model visible in pairs, models do, and then we'll indent this whole thing and then add a new end down here. So basically what this does is it creates we iterate through this object and we create two variables for this loop, the model, which is this part, and visible, which is this part. And then pairs, so we have two different loops here. One of them uses pairs, one of them is iPairs. iPairs is whenever you have a list, pairs is whenever you have an object. So now this checks most of the things that we need to do here, except this won't work because it will change this variable, but it won't actually change the value in the object, which we need to do, or else it'll toggle once, and then even if you keep clicking on it, it won't change again. So we need to say model equals not visible. So this might seem like it sets it to not being visible, but what this actually does is it inverts the value of visible here. So if visible is true, it'd be false. If visible is false, it'd be true. And then this part just references whichever current model we're working with. And again, we can't use this because this does not actually reflect anything in our object. So whenever we click, it disappears, that reappears, and we can work these two things completely independently of each other, and it will still work fine. So yeah, that's about all there is to it. I hope you guys enjoyed this video, and I will see you again next time. Bye, guys.